Hey everybody, welcome back to the channel. I told you I got you, man. I told you I got you. Now we are starting the introduction to Transformers. Not the robots in disguise. Transformers that you see around your neighborhood. Transformers that you see on these commercial job site. Transformers that you see on this industrial job site. There's a whole type of and a lot of Transformer. But don't worry, you guys. I'm gonna teach you through it. I'm gonna talk you with it. And, take two. I don't like that one.
Each coated with insulation. These sheets are tightly held together to minimize the air gap currents by providing high resistance, thus minimizing their formation. And that's how a laminated core minimizes eddy currents and makes the transfer of energy more efficient. As we know, an electric motor is used to convert electrical energy into mechanical energy. However, a transformer is different. It does not convert electrical energy into any other form. Instead, it transfers electrical energy from one voltage level to another. The input and output voltage of a transformer are related according to its transformation ratio. Here, NP and NS are number of turns in the primary and secondary winding, respectively. If the number of turns in the secondary winding are higher than on the primary winding, the voltage induced in the secondary winding is higher compared to the primary input voltage, while the current in the secondary winding is lower because energy is conserved. This type of transformer is called a step-up transformer, and it is used for increasing the voltage level of an AC supply. On the other hand, if the primary winding has more turns compared to the secondary winding, the voltage induced in the secondary winding is lower than the primary input voltage, and the secondary current is higher. This type of transformer is called a step-down transformer, and it is used for decreasing the voltage level of an AC supply. An important point to note is that a transformer does not affect the frequency of the AC supply. The input and output of the transformer have different voltages, but the same frequency. Now, let's understand what are transformer tappings. A tapping in a transformer is a connection point along the winding that allow access to a specific portion of the coil. Tappings are used to adjust the voltage ratio between the primary and secondary windings, enabling the transformer to provide different output voltages. Based on how the primary and secondary windings are placed around the laminated core, transformers are generally of two types: core-type transformers and shell-type transformers. As we have already discussed core-type transformers, let's now focus on shell-type transformers. The working principle of a shell-type transformer is the same as that of a core-type transformer. The only difference is in their structure. A shell-type transformer also has primary and secondary windings placed concentrically on a laminated ferromagnetic core. In this design, the core surrounds a significant portion of the windings. Both core and shell-type transformers can produce similar characteristics. The choice between core and shell-type construction is typically determined by factors such as cost, insulation stress, heat distribution, and weight. Both of these are single-phase transformers, meaning they operate on a single-phase AC supply. Single-phase distribution transformers are also an integral part of power system. These